Pascal's triangle, right? One of the huge applications of Pascal's triangle is to help us expand binomial terms, right? So that question number 1 is based on that. Expand x plus 2 to the power of 5. Now, since the power is 5, we have to go to the 5th row of the Pascal's triangle to find the coefficients, right? So let's first make our Pascal's triangle, and let's start with number 1, right? It always starts with number 1. So as we go down, so let's try to make it like this. So as we go down on either side, then there's only one way to go down. So we have 1 and 1, right? And this is the 0th row, and we have come to the first row. So here the expansion of a plus b to the power of 1 will be a plus b, correct? Now, further if we go down, so there's only one way going diagonally towards this left side, and also on the right side, there's only one way to go, correct? So here we'll have 1 and 1. But to reach this place, we have got two ways. One from this side, the other one from here. So there are two ways to go. This is our second row, correct? And like a plus b whole square will be a square plus 2ab plus b square, correct? Where you'll find that 1, 2 and 1 are the coefficients, right? And a and b, if they are the terms, then the degree of a starts with 2, decreases 1 each time, and degree of b starts with 0, increases by 1 each time. And that is what is followed all throughout, and we will see exactly what happens at x plus 2 to the power of 5 in just a minute. So we go further down here, and then the numbers we get on this side always 1, on the wings you can say, right? And when you combine 1 and 2, you get 3, and 2 plus 1 is also 3, right? That is the third row. It will help us to find a plus b to the power of 3. And now we are generating the fourth row coefficients. So in the fourth row, we can have 1s here, and 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and 1 here, correct? And then we further go down, and that's our row, 5th row, right? So on the sides we have 1s always, correct? Because if you go like this, there's only one way of going, left side or the right side, right? So this is actually my left and this is my right. Okay, now here this is 1. When you combine the consecutive terms before this, we see 1 plus 4 is 5, and 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5. Now, if we are interested in expanding x plus 2 to the power of 5, then we need to look into the 5th row. And what does it give? It gives us 1, 2, 3, 4, 5, 6 coefficients. And these are for the 6 terms which we expect in the expansion of x plus 2 to the power of 5. Okay? So, row number you can see could be seen from this line. So 1, 2, 3, 4 is the row number which you can see. Do you see this line? So that gives you the row number, and that's the 5 we are interested in, correct? Now let's try to expand it and see how does it work out, right? So first thing is, because the exponent was 5, we went to the 5th row, right? You remember this is the 0th row when we start with. So here is the 0th row, right? And as we go down, this is my first row, then this is my second row, this is my third row, this is 4th, and this one is my 5th row, correct? Now, what we can do is, we can just expand it in right. Now, we know there are terms, and the first term will be x to the power of 5. So, what we do is, the coefficient, this coefficient is for the first term, which is 1, right? So we just don't write 1, it is assumed, and we get here x to the power of 5. The exponents have to add up to 5 always, and the exponents start with the number, the maximum number. Let's say it is n, it will start with n for the first term, right? So x to the power of 5 and 2 to the power of 0, which is 1, correct? Now next term will be having coefficient of 5. So first we'll write coefficient of 5, and a for us is x, right? So x to the power of 4, 1 less than 5, and the next term b is 2 for us. So this is 2 to the power of 1, correct? Plus 10 is the coefficient for the third term. So we say 10, and x, it will decrease by 1, it will become cube, and 2 will increase by 1. It was 1 here, and now 2 square. 3 plus 2 is 5. Do you see that? And the next term will be after 10 again 10. So 1, 2, 3, fourth term is here with 10, and x degree is decreased by 1, so we get 2. 2 degree will increase by 1, so we get 3 here, correct? So this is our this term, right? Now 5 is our coefficient. X 1 less than 2 is 1, 2, 1 more than 3, so it becomes 4. You can see 4 plus 1 is 5, and the last term, which will be the sixth term for us, will be 2 to the power of 5. So see, 1, 2, 3, 4, 5, 6 terms. 1, 2, 3, 4, 5, 6 terms. Coefficients are 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1, correct? And the degrees you can count 5, 4 plus 1, 5, 3 plus 2, 5, 2 plus 3, 5, 1 plus 4, 5, and 5. These are our A's and B's. This is my A, that is my B. Do you see that? So A power is 5 first, and it decreases by 1 each time, correct? X to the power of 0. Now for the B, power increases from 0. 2 to the power of 0 is 1, so you don't see it here, right? 2 to the power of 1, 2, 3, 4, and 5. So this is the Pascal's triangle use and application to expand a binomial like x plus 2 to the power of 5. I hope you understand it, right? For you as an exercise, if I would have written minus 2 here, then how would it change all this? Think about it. So if I write minus 2 here, for example, let me do it here for you, right? If I write minus 2 here, then what will happen? 2 to the power of 1, if it is minus, it will be minus, right? So this will become negative. 2 square will make it positive, so that remains positive. But 2 cube minus will be minus, right? So 2 cube minus will be minus 8. So that will make it negative 2. And here 2 to the power of 4, negative 2 to the power of 4 is positive. So this remains positive. But negative 2 to the power of 5 is negative. So we'll find a change. Alternate terms will have negative, where the exponent of 2 is odd degree, correct? So that change will bring in this change in our expansion of the binomial x plus 2 to the power of 5. Okay, I hope you appreciate it. Have a good look at it. Okay, thank you.